This is the Southern Railway line of Austrian Federal Railways. This line is an important link from Austria to its southern neighbours, Italy, Slovenia and Croatia. The line runs from the Upper Murtal in Styria into the Klagenfurt Basin across the Neumarkt Ridge. A typical alpine route with steep gradients and tight curves. For quite some time, a speed restriction has been imposed on the 4-kilometre-long section of track. The negative features of the track, such as damaged timber sleepers, gauge widening by up to 35 mm and defective rails, have made it necessary to perform complete rehabilitation of the track. The main objectives of the project are complete rehabilitation of the subsoil, ballast cleaning of those sections on a rock base, and finally installation of the new track. During the whole time, all normal traffic must continue uninterrupted on the adjacent track. These are targets that can only be met by fully mechanized work methods using modern track maintenance machines. The efficiency of every work site depends heavily on the quality of the advanced planning. This involves ordering the quantities of material needed, drawing up operation schedules for machines and personnel, as well as coordination of the track contractors and the railway departments. The necessary data and information are taken from geological reports and inspections, and from measuring runs carried out by recording cars, such as the Austrian Federal Railway's EM250 track recording car. The start of construction work on the line. In preparation, all the vegetation along the track is cleared away. New cable ducts are laid, drainage ditches are dug out, and foundations are prepared for the erection of noise protection walls. The first stage of work is the rehabilitation of the subsoil. Here, the ballast and the old formation material are removed completely. After this, the geotextile is laid with a slight crossfall to optimize the drainage. Finally, the new formation protective layer and the ballast are placed in the track. Here, the AHM 800R formation rehabilitation machine shows its flexibility and high productivity. The machine carries out all work processes, from excavation of the old material and recycling, as well as the perfect installation of the new formation protective layer, including the geotextile. 2 excavating chains go into action. The first chain removes the reusable upper layer of ballast. The second chain excavates the remaining material. The reusable ballast is carried away on conveyor belts and taken to the crushing plant for processing. From here, the material is taken to the mixer, where it's combined with water and the formation material to produce the sand-gravel mixture for the new formation protective layer. After excavation is completed, the subsoil formation is smoothed. Immediately after this, the geotextile is laid and the new formation protective material is placed. To ensure the best possible consolidation, the water content of the mixture is checked and regulated continuously. Large plate consolidators smooth and compact the sand-gravel mixture to the required level. The installation of the new formation is now complete. All requirements for a perfect formation protective layer have been fulfilled, without having to remove the track and with rail services continuing on the adjacent track. On some sections of this line, the ballast is lying on a rock bed. On these sections, ballast cleaning will be carried out instead of formation rehabilitation. When the bearing capacity is reduced and the moisture content is too high, this will have a negative effect, particularly on timber sleepers. These are the fundamental problems caused by a polluted ballast bed. These problems can be solved effectively and cost efficiently by the application of modern ballast cleaning machines. The RM80 ballast cleaning machine used here is a proven machine that has worked reliably for many years. The excavating chain removes the polluted ballast. An important factor is the exact guidance of the chain with the help of the cutter bar. The polluted ballast is taken to the multiple layer screening unit. In many respects, the clean ballast has a higher quality than the new ballast, and it's also much cheaper. The ballast is returned to the track behind the excavating chain. Now we go back to the section with the new formation protective layer. Here, the new ballast is being placed. The ballast bed will be constructed in several layers, so the first so-called safety tamping pass is carried out at this stage. This is done primarily to consolidate the lowest layer of ballast. On the other hand, it also facilitates the operation of the following machines. A mechanized maintenance train is used for this work. The mechanized maintenance train working here is led by an 09 3X tamping express, which is a continuous action 3-sleeper tamping machine. This is followed by a ballast plough, SSP 110SW, to profile the ballast bed. The last machine in the trio, a DGS 62N dynamic track stabilizer, compacts the lowest layer of ballast. The third major stage of work is now the renewal of the track components. The old rails and sleepers are removed, new rails and sleepers are laid. The newly delivered rails are laid alongside the track using a special unloading device. Before being unloaded, the new rails are connected provisionally by fish plates. In the next pass, all the rail fastenings are released and picked up by the rotating magnetic drum. Before the relaying train goes into operation, the old rails are loaded onto wagons and taken away. The third major task in the course of the track rehabilitation, as it is being performed here, is to lay new sleepers and new rails. Track relaying trains of modern design carry out this stage of work like a well-coordinated assembly line. As we see here, the machine picks up the new rails laid next to the track. Then, the old sleepers are removed. Working right behind the crawler track are the excavating chain and the profiling device, which ensure the required lowering of the ballast and an excellent foundation for the sleepers. Now the new rails are positioned on the sleepers. The rear section of the relaying train is already running on the newly laid rails. An important element of the relaying train is the transport logistics for taking away the old sleepers and bringing in the new sleepers. This work is performed here by 2 gantry units. The rails are welded together before they are fastened down. A mobile flash butt welding machine is used for this. Here the preparations for welding can be seen. The rails are brought into the right position, and then the welding head is lowered. The rail ends are heated because of their electrical resistance using current with a low voltage and high amperage, and welded at a suitable temperature. As no foreign substance is used, the welding process is continuous and homogeneous. The welding is performed fully automatically, and this assures a consistently high quality. The welding machine is followed by the 8-spindle power wrench, which bolts the rails fully automatically to the sleepers. In the next operation, the welds are ground smooth. To give the new track the required stability for train services, tamping is performed on the new track. This process begins with placement of additional ballast. Finally, the new track is fixed in a perfect geometrical position by tamping and stabilization. Another layer of new ballast is unloaded in the newly laid track. This is followed by the mechanized maintenance train. The procedure is basically the same as for the safety tamping pass. The machines on this worksite are also the same as those used before. The mechanized maintenance train is led by a continuous action 3-sleeper tamping machine, which performs leveling, lining, lifting and tamping of the track. Following behind, a ballast plough to profile the ballast bed. And finally, a dynamic track stabilizer to consolidate the ballast and raise the track's resistance to lateral displacement. Tamping of the new track is performed in several passes. Before tamping is carried out, the MSAT 120 track survey car measures the parameters of the track and transmits these values to the mechanized maintenance train, which then performs the next pass on the basis of these data. Step by step, the desired quality of the new track is achieved. Also important, in order to achieve the best quality initial quality of the track, it has meanwhile become international standard procedure to grind the surface of the new rails. On this line, the new rails are ground by a grinding machine for tracks and switches using oscillating grinding stones. Machines of this type produce a smooth rail surface and therefore assure high travelling comfort. The track is now ready for the acceptance measurement. All data are stored and can be retrieved when required for later maintenance of the track. After this surveying, the section of track can be reopened to traffic. The railway line shown here poses great challenges to the application of heavy-duty machinery due to the tight curves. As can be seen, even for these special circumstances, Plasser and Theurer can offer a whole range of machines, which makes it possible to carry out fully mechanized rehabilitation of the track. A major reason for the functionality and quality of these machines can be found in the continual optimization of the work units and components used for over 5 decades. For every maintenance project, there are solutions available which can produce an accurate result in a very short time, and thus meet the high demands for cost efficiency, just as demonstrated in this track rehabilitation on an alpine track on the Southern Railway line in Austria.